Okay, this is exercise 11 from your book, and all the problems that you're going to find in this section have to do with these equations. Some of you went ahead and started looking at them. You can expand it, start looking at, 7 divides 2x minus 4, but I'm pretty lazy. The first thing, one of the things I always say is mathematicians are lazy because they try to figure out the cleanest way to do it, the quickest way to figure out how to solve a problem. So I'm looking at saying I don't want to deal with any formulas. What I first noticed is that 2 and 4 are multiples of each other. So wouldn't it be nice if I could just whack that 2 out of both sides? Then I have x equals on the right side, or x is congruent on the right side, and I've solved the equation. So I look at 2, it's 1 times 2, and 4 is 2 times 2. And from the previous theorem, my c is 2, and my a and b are 1 and 2, and my m is the 7. So is it true that c and m is equal to 1? Are they relatively prime? Is that true? Because if it's true, I can apply that theorem and just cancel the 2 out of both sides. True? False? You are sleeping. And you're very good at sleeping with your eyes open. You must have had 3 years of math behind you. Is it true? Matt?
Yes.
Yes, it's true. Because Matt said so. I knew he was going to say that. So I put it up here in advance. So I can cancel the 2 from both sides. And that's the solution. So it's not going to be x equals a number. It's going to be x is congruent to, that's how you solve it. And what does it say? How do you, actually I should have done this, but how do you show something's a solution when you're showing people who are working on mathematics at a lower level than you? How do you tell them to prove something's a solution? You put it back in the equation. So you take any x that's congruent to 2 mod 7, put it back in the equation, and see if it works. So maybe next time we'll do that so you can actually see it with a number. Here's another one. 2x is congruent to 1 mod 7. And they ask you to solve, and they give you a hint that 1 is congruent to 8 mod 7. Hints are devastating because you can get, it's kind of like the cookie you're not supposed to eat. You keep looking and going, how did I work that hint in? Instead of trying to directly solve the problem. I couldn't help it. They said hint right at the side, and I started looking at it. So I, looking at the hint and thinking, okay, I'm going to use, at first I thought they wanted me to multiply both sides of that hint with something. So I spent some time, so it's wasted time. I'm trying to look at this hint and figure out what context it goes into. And only later did I realize, wait a minute, I'm going to go to the list of properties and see if that hint helps me in any way in the properties. And I saw immediately that my a could be 2x, and my b could be 1, and my c could be 7. And from that application, I get 2x is congruent to 8 mod 7. And I told you that I went through some shenanigans for a while because, first of all, I have no pride. Second, it's to tell you that hints can sometimes do that to you. You get focused on the hint, like how does that work in there? So you can spend some time kind of trying to figure out how that fits into whatever they're telling you. So it happens to me too. Now I can cancel the 2 from both sides, and I can do that because the 2 and the 7 are relatively prime, as I did before, and I get x alone. So the homework is not problem 12, the homework is exercise 12 on page 31. It's along the same lines where you're going to have to look at those properties and try to figure it out. And these will appear on the test. You know what, there's not many problems in his book like this, so I would say Google search some problems. Somebody's got to have a final exam. You know what you do is go final exam, Underwood-Dudley, number theory, congruences, and equations. And then somebody will have a final exam posted, usually with solutions. So you can look at the solution too. And I don't want to